Good afternoon. So I guess we'll restart. Apologies for lunch being late and presentations being early. It's probably better the other way around. But just to remind you, you've got questionnaires and to fill in the response form. And I understand from Peter there's a goodie for filling it in or something. So I'm not sure what the goodie is. It might be just more PowerPoint, but. So I'd like to introduce our first speaker this afternoon. This is Brian from Microsemi. We've talked a lot about hardware and verification, things like that. Here we're going to take about the software side of the view, which is, I think, is quite interesting. That, as I said, Brian gave this presentation last year at Jenkins World, and the video for that's up online on YouTube, which I thought it's a pretty good presentation. So we asked him to give us a view of this. So over to you, Brian.
Thank you, Bill. Good afternoon. Thank you for attending my presentation today. My name is Brian Vandegriend, and I'm with Microsemi, and I'm based in Vancouver, Canada. Oops. So I know we talked a lot about Spectrum LSF, especially in data centers and with high compute infrastructure. My presentation is a little bit focused on a different application space, and that's with regards to deploying the device driver software for our customers. So my talk is focused around integrating two very strong tools together, Spectrum LSF and Jenkins. And as Bill mentioned, I presented a similar presentation last year at the Jenkins World Conference. And I'd like to thank IBM and Bill for inviting me to speak this afternoon. So a little bit about myself before I get into the material. I've been in the industry for over 15 years. I started off as an ASIC designer and verifier. And in the last 5 years, I transitioned into software, focusing on testing our device drivers for our ASICs. I was originally part of PMC, and we were acquired recently by Microsemi. And Microsemi provides a number of different semiconductor solutions, and the area that I'm focused in is with communications. So as I mentioned, much of the focus today has been around data centers and maximizing throughput with very large LSF clusters. I'm looking at it from a slightly different perspective. When I joined the software team a couple years ago, I knew that they could actually have a lot of benefit from incorporating Spectrum LSF into managing the resources in our software lab. We use hardware evaluation boards to do our system level testing, and I'll be telling you how those were allocated using a manual approach. And there was a lot of benefits towards, of course, adopting Spectrum LSF to automate and to simplify the resource sharing and the resource management. And I coupled that with Jenkins, and I'll be explaining a little bit more about Jenkins, but the two tools together definitely helped us in the goal of what is called continuous integration or continuous delivery. And it's all about getting software releases to our customers faster and more efficiently. So I'll be covering several topics this afternoon. I'll first give you an overview of our build and test environment so you have a good understanding of our infrastructure. I'll provide some high-level concepts around Jenkins, just so you get a feel for what it actually provides. And then I'll talk about the old method, how we allocated boards, and then our new method that we use today. And then from there, I'll give you the nuts and bolts behind how we actually integrated the two tools together. And since I was responsible for rolling this out to the team and maintaining it and supporting it over the last couple of years, I've gained some valuable experience, and I boiled it down into 5 tips that I want to share. And hopefully you could take away some valuable tips that you could look at incorporating as well. And then finally, I'll conclude by describing the benefits that were realized. So our software team is responsible for developing, testing, and supporting our device drivers. And really, these drivers are focused around our optical Ethernet networking SoCs. They're very high capacity. So a typical application for these SoCs would be transporting 10 gigabit and 100 gigabit Ethernet over optical links. So very high capacity, and they're primarily used in connecting data centers together and also in our metro networks. Now, the device driver is very low level. It's written in C, has about 150,000 lines of code. And we use the Jenkins platform to do the continuous build and continuous test of the software driver. What I mean by that is with every code commit into our Subversion repository, Jenkins automatically triggers the building and compiling of the software code, and then if that's successful, it then gets system tested. And the whole process is automated, and we strive to get releases out to our customers in around every 2 to 4 weeks, depending upon requirements and needs. Now, the whole process is automated, and Jenkins takes care of that. And the only manual step is actually posting the release to the web portal. The part with continuous delivery, it essentially means that every check-in could potentially become a shippable release, because you're basically pushing the software change through the entire process, and basically all the way from unit testing to system testing. So our system level testing is done using hardware evaluation boards in our software lab. And you can see from the picture on the right that basically we have 3 devices on the board. The 2 outside devices generate traffic for the middle device, which is typically our device under test. Now, these 3 devices, along with the FPGA, are connected to a COM Express module, which is Intel-based and it's running Linux. Since it's running Linux, of course, we can then run the LSF processes, and LSF basically sees this as a LSF slave or host. And so from this, we're able to relatively easily put all of our boards into an LSF farm, and that has definitely helped in with reducing regression test times. So just 2 slides on Jenkins, just to introduce at a high level what it does. So Jenkins is an open source automation server that can essentially build, deploy, and automate any project. Typically, it's used for software projects, and I'm trying to encourage other teams within our organization to also look at it for using with their hardware projects. Now, for larger tier companies, while Jenkins is open source and has a pretty strong open source community, there's a company called CloudBees that provides enterprise class support and also plugins to address things like security and stability. So for larger companies, that's something that you may want to consider. Now, Jenkins provides a number of powerful features. It first of all helps you to automate your projects with multiple stages. So, for instance, when you check in new code, you might have to compile it, and so basically you'll create a number of Jenkins jobs. So you might have a Jenkins job for compiling your code. You might have another one for running unit tests, and another one for running system tests, and perhaps a 4th one for deploying the release. And so typically you could chain these jobs together either sequentially or in parallel with Jenkins, and you build out and automate your project in that fashion. Now, larger projects or larger Jenkins instances tend to use a master-slave architecture. So you can see here the picture on the right is just a screenshot from our Jenkins instance. It's relatively small. We have a single master and then a couple of slave servers. The master essentially coordinates the activity across the slave, so it basically allocates and handles the jobs, and then the jobs themselves are actually run on the slave machines. These could be Windows servers, it could be Linux, either VMs or bare OS. Or it could be even, you could even have Docker containers that get spawned up on a cloud surface or a cloud service. So there's a lot of flexibility in the different types of slaves or agents that you run your jobs on. One of the newer features with Jenkins is the idea of pipelines. And pipelines is a great way of actually visualizing the building and deploying of your project through its stages. So on the right-hand side, you'll see a screenshot from just a mocked-up example that I created that shows 4 stages for a particular project: building, unit testing, system testing, and then creating the release. And it allows you to very easily visualize your project as it gets compiled and tested. The pipelines provide a number of nice features. Instead of building up the configuration using the web-based interface, pipelines are actually described as code, which makes them a lot more portable. And with that, also you get additional constructs such as the ability to fork and join steps within a pipeline job, or you can do parallelization and things like that. So it is definitely a powerful feature, and it's something that Jenkins has rolled out quite recently. So this was the old method that we used for allocating boards, and I'm sure for those that remember the days before LSF, I'm sure it's all too familiar. So when I joined, our hardware boards were essentially allocated to users just manually. So we had a spreadsheet or a table on a wiki that listed out the board assignments. We reserved a few boards for Jenkins to use exclusively for running its automated regression testing. Now, of course, this might work fine for a couple of users in a single site, but of course, as you scale up, it quickly becomes unworkable, right? There was a lot of time being wasted. Engineers, if their board was being used, they would kind of hunt around, try to find a free board. Also, when the engineers went home, we couldn't deploy the free boards to our regression testing to increase throughput. So, of course, Spectrum LSF was a natural fit for this particular problem, and it was relatively easy to deploy this onto our hardware evaluation boards as, like I said, they're simply, from LSF's perspective, they're simply just Linux computers. So the use models should be quite familiar. Basically, both users and Jenkins submits their jobs to LSF or their tests to LSF. And then we use a lower priority queue for Jenkins so that Jenkins is able to make use of extra capacity when it's not being in demand from the engineers. And then, of course, since LSF supports resource constraints, since we have a few different board types with a few different variations, we can easily handle that with the resource types through the bsub command. So, of course, there's a number of advantages that we quickly realized. It simplified the user experience. No longer did they have to hunt around to find a free board. LSF, granted a board to them, and of course, we used various mechanisms in LSF to increase the reliability of the system, and I'll talk about that in a few minutes. And probably most importantly, we got results faster, and I think that's one of the key outcomes. We were able to, reduce our test times by getting access to a greater number of boards. And when the engineers got back in the morning, they would have boards available for them as well. So this slide basically illustrates the nuts and bolts of how we integrated the two tools together. Jenkins essentially is a tool that automates scripts, right? And so we used a Python script to run a regression. So what this Python script did is that it fetched our test list, which we stored in a Jira in our Jira system. So we fetched our test list, which contained, the list of tests, test name, the command for running the tests, and so on. And the script would dispatch the tests as individual jobs to LSF with those resource constraints. As LSF was dispatching the tests to the boards, our script would then scan the status from LSF and also the log files and print out to a console log in real time, which we could then look at through the Jenkins interface. Once all the tests finished, we had plain text log files, which we then parsed and converted into XML into what's called the JUnit format. It's a format that Jenkins understands, and then we can use Jenkins to display the test results through its interface. And so you see the two screenshots on the bottom. One shows the build history over time and the results, and then the other one shows the specific test results, and you can actually follow the hyperlinks and drill down into the failures, and you can look at individual log files all through the Jenkins interface. So when I was in the process of rolling this out, I looked around, and there was another solution that was being presented from a conference a few years back, and the suggestion there was to actually, instead of using LSF, the solution presented was to use, to run a Jenkins slave process on each board. So essentially, you would have a series of boards that were dedicated to Jenkins as slaves, and then Jenkins would dispatch the Jenkins jobs to those boards. Now, this wasn't a great solution, and it had a number of disadvantages. You're now partitioning your pool of boards into two, and then you have greater inefficiency. You also, here I'm illustrating that if you have 400 tests, you have to somehow divide those 400 tests up into, say, 10 jobs, and then you have to try to equally partition those tests across the 10 boards, and that's not an easy process. And then also, if you have all the boards available to Jenkins, you can't simply just reallocate the mix. And so it's a much more effective solution to basically put all the boards into LSF and have LSF take care of all the resource management for you. So now I'll present some tips that I've gained from my experience. One of the things that we realized is that we created a pretty powerful mechanism for automating and running our system tests using the code in the trunk. But what we wanted to do was we wanted to give the ability for software developers, as they were testing out new features or they were doing bug fixes, we wanted them to give the ability to run the same automated tests on their code changes before actually committing the code to the trunk. So we did this by creating a couple of new jobs in Jenkins, which allows users to submit their private workspaces to Jenkins, and then basically Jenkins would then compile their code and run the suite of tests against their private workspace. And then you can accomplish this in Jenkins through the use of parameters. So basically, and you see from the screenshot on the right how Jenkins provides the ability for users to input these parameters before the job starts, and these get passed in as environment variables. So through this mechanism, we noticed that we were able to get better quality code commits going into our trunk, which led to a more stable trunk, and that definitely helped making sure that the code in the trunk was solid and we didn't have as many bugs being introduced. One of the other things we did, initially these user regressions were being put after the main regression, and so oftentimes the user would have to wait quite some time before their regression got to the top of the queue. So we actually used a capability within LSF to parallelize the sets of regressions, so that the user regression and the main regression would actually be running in parallel, so that the user would get quicker results for their changes. The next problem that we faced was sometimes we have our boards get into a corrupted state. I mean, it happens with servers too, but I think less often. So when a board is corrupted, it will cause the next set of tests that run on it to fail very quickly. And essentially, the corrupted board is like a black hole, right? It sucks all the tests in, kills them, and you end up with a dead regression. So fortunately, LSF has a couple of good mechanisms for dealing with this type of problem. First thing is we used LSF to monitor the exit rate coming from the boards. So for instance, if 5 tests fail within 30 seconds on the same board, LSF takes the board offline. The second thing that we did is sometimes a board gets left in a different state than what the next test assumes. And so what we did is we used the pre-execution capability to run a board initialization script on the board prior to starting the test. Now, the board initialization script would also do a few checks just to make sure that everything was stable. If those checks failed, then it would return an exit code, and LSF would take the board offline and actually find a different board for the test. And then finally, once the test finished, we would actually scan the log file, and we would look for common errors that indicated a board issue. And if we came across such errors, we would then re-queue the test in LSF, and it would run it a second time. And so these techniques together have definitely increased the reliability of the system, and also have ensured that we get better quality results from our automated regressions. Now, so the last slide talked about taking boards offline. Ideally, you have a self-healing system, so you don't need humans to intervene to get the boards back online. So we actually put together a board monitoring script. One of the other nice things about Jenkins is that it can also automate a lot of your maintenance tasks. And so Jenkins would periodically run this board monitoring script, which would basically collect a list of offline boards, and then it would attempt to bring them back online. So it would start with resets, and if that didn't work, then of course we would do a power cycle. If a board did not come back online after these steps, the script would fail. It would return an exit code, and then Jenkins has the ability to send email notification when the job fails. And so, of course, we just get a high priority email in our inbox saying that one or more boards has not come back online. The fourth thing that we did is we basically qualified our boards before putting them into LSF. So sometimes as the boards get reworked, there can be a manufacturing issue that gets introduced, and it would sometimes cause boards to fail tests intermittently. And so simply what we did is we just took a suite of tests with a stable software release, and we basically just ran a battery of tests with 10 iterations across the new boards, and we basically just looked for failures. And then we used an LSF group to create a list of golden boards, and then of course our automated regressions would only use those particular boards. The last tip essentially has to deal with flaky tests. Since we have a fairly complex system, sometimes we have tests that would fail intermittently, and it made it difficult to get clean regression results. So a flaky test is a test that sometimes will pass or fail with the same software release. And so what we did to help work around this problem is that when we had a test failure from our regression, we would actually rerun the test 3 times. And if all the reruns have passed, and we had previously flagged this test to be flaky, we would then change the test result from a failed to a skipped. Now, we would only do this if we had already identified the test to be flaky and had put it in our backlog as something to get investigated. But by rerunning the failures 3 times, it very quickly gave us more results when the regression finished, and we could look at the failures and then look at whether the reruns have all passed or if there was some intermittent failures as well. So the way that we handle this within Jenkins is that with the test results, you really have 3 states, either it passed or failed, but they also had a third category called skipped. Generally, this is used when tests are actually not run, But since we couldn't create a new test category, we used the skipped column to indicate that it was a flaky test that failed that was subsequently rerun, and that all the reruns have passed. And so that's what the screenshot on the bottom shows. So to conclude, by integrating Jenkins and Spectrum LSF together, we realized a number of benefits. First of all, it simplified the user experience. It was very easy for a user to gain access to a board, and they didn't have to spend time trying to find one. Through the various mechanisms that I explained, we increased our overall reliability of the system. We had less issues with corrupted boards, and we had better success with the tests that ran because of the board initialization script. And then finally, and probably most importantly, it helped to shorten our automated regression test cycles, and that meant getting software releases out to our customers faster. And I think at the end of the day, that's what really matters. Are there any questions?
Is this one on? Okay, yeah. I think you showed in your early charts, I think that many people work on the boards remotely, correct? So
that's right.
You have it. So how robust was this? I mean, basically when the team in the Far East or in Europe was trying to get to Vancouver in the middle of the night and so on, is this pretty much self-running? Did you were able to make it robust enough to keep it up? Or does it still require local attention as well?
Sorry, are you asking whether, like using our old method, whether it was it maintainable, or are you talking about our new method?
No, our new method. Basically, if you would have nobody in Vancouver, I think where the boards are.
That's right.
Would it still run? I mean, how much local attention is required to keep this sort of system running?
Right now, it requires almost no effort to keep this running. I mean, the fact that we can automatically deal with corrupted boards and bring them back online really helped to reduce the amount of effort in supporting this. So, I have one engineer that maybe spends 10% of his time on just kind of supporting the system. I mean, it's not a large system, but there's enough complexity that I think he can appreciate. So, so yeah, probably 10% of the time for one engineer.
Okay, excellent. Yeah. Thank you.
Any other questions? Great, thank you very much.
Thank you, Brian.